Hello and welcome to this section of the Algebra Tutor. Here we're going to continue talking about polynomials. We're going to start to learn how to divide polynomials. And we've actually kind of broken this topic up into two broad categories. This section will be dividing polynomials by monomials, and I'll explain what that means in a minute. And then in the next section, it'll be a little bit more complicated kind of division where you're dividing polynomials by polynomials. So basically, when you're dividing by a monomial, you're dividing by a smaller term, and so it's easier to do. When you're dividing by a polynomial, which we'll do in the next section, you're dividing by larger things, and so it's going to take a few more steps. But in both cases, just like everything we've learned so far, it's all approachable, it's all easy to do once you understand the concepts and once you get your practice and your confidence. So let's start by talking about dividing polynomials by monomials and give an example to show you what I'm talking about. What if you have something like this? 6x plus 9y, and I'm going to put a fraction bar, which means division. I'm dividing by 3 times x times y. And I'm asking you, perform this division, or perform this simplification, division, same thing. All right, how do you do it? Well, notice on the top we have a polynomial. It's a binomial in this case because I have two terms up here. And I'm dividing by a monomial, which means I'm dividing by basically one term, one little nugget. It can have things multiplied there, but only one little guy down there that I'm dividing by. So there's one thing that you need to know in order to be able to solve these problems. I don't really want to call it a trick because I don't really believe in math tricks, but it is one of these little things that if you just remember it, it can help you in so many different situations. It's one of those things that you don't pick up too much in books as a rule, but I'm going to tell you right now, I use it constantly. So anytime you have a term on top of a fraction like this, and you're dividing by something on the bottom, and the term on the top has a plus sign, and the guy on the bottom is a single item, then the way you can rewrite it is as follows. Now let me rewrite it, and you'll kind of scratch your head and wonder why, and then I'll show you why. So don't worry so much if you don't quite understand in the beginning. This is equal to 6x over 3xy plus 9y over 3xy. What I have done is taken the original expression and split it up into two smaller expressions. These are going to be easier to deal with and easier to actually solve the problem, and so I'll be able to get some work done over here. Everything over here is tough to do because it's all tied up in this plus sign on the top of the fraction. But I can break it up by taking one of the terms divided by the bottom and the other term divided by the bottom, and the plus sign comes from the fact that there's a plus sign there. Now you might ask, you should ask actually, why is this the case? You know, a lot of times in algebra, I show you stuff, or the teacher will show you stuff, or the book will show you something, and the student will say, well, here comes another rule. It's another rule I have to learn. Well, this isn't really like another rule. It's something you probably already know, but you don't realize how useful it is. So let me show you. What if I ask you, forget about this, don't even worry about this. I'm going to ask you to add some fractions. What is 3/4 plus 7/4? How do you add these fractions together? Well, the denominator is the same, so that stays the same. And then you add the top, 3 plus 7, right? And of course you know from doing this that 3 plus 7 is 10, so 10/4. So I might ask you, add these fractions together and you're going to get 10/4 because you know you keep the bottom and you know you add the tops together because I already have a common denominator. Now I hope you can kind of see the parallel that I'm trying to draw. This guy is kind of like this over here. See, what I have is something on the bottom, in this case it's a 4, two things added together on the top. And this equal sign means that it's equal to taking one of these guys and taking and dividing by the bottom, and the other guy and taking and dividing by the bottom with a plus sign linking them. So you should be able to see the direct parallel between this and this. Over here is like what I have right here. All I've done is taken one term, divide by the bottom, one term, divide by the other bottom, and that's it. And now that I have introduced it in terms of fractions, you should be able to convince yourself why this makes sense, because I can go the other way. If I cover this up and I say, add these fractions together, once you get over your initial worry about it, you'll realize I have a common denominator here. So my denominator in the answer is going to be the same. And all I do is I add what's on the top. But since I have different terms here, I can't really, simplify them, so I just say 6x plus 9y goes on the top. So this is like adding fractions here. So I guess I'm trying to go through all of this to make sure that you understand that anytime you have a fraction with something added on the top like this, and then a single item on the bottom can always be broken up. Always, always can be broken up the way I've done it here. All right, now let me erase the board real quick and show you how to finish the problem. All right, so we've gotten to this point. How do we finish the problem? Now we see we have, if you remember how to simplify expressions, anytime you have something on the top of a fraction and you also have it on the bottom of a fraction, you can cancel it. It's because they're dividing out basically and giving you 1. So here I have an x on the top and an x on the bottom. So that's going to basically give me 1. And then over here I have a 6 divided by 3. So basically this is going to give me 2, right? You can think of it as dividing the top by 3 and the bottom by 3. And so you're going to get a 1 down here and a 2 up there. But it's the same thing as division. 6 divided by 3 is 2. So when you simplify all this, for this term, you're going to get 2 divided by y. Because the x's are gone, the 3 is gone, the 6 turned into a 2, and I still have my y. Now over here, I see I have a y on top and a y on bottom, so they can cancel. And I also see that I have a plus sign. 9 divided by 3 is going to give me 3. That's going to be on the top. And then I'm going to be left with x on the bottom, because everything else is canceled. So I've done the division. That number goes up here. The variable here is left over. So this is the final answer. If someone said, simplify this expression or perform this division, because this is like this divided by this, the easiest way to do it is to split it up into 2 terms and then deal with the cancellations, and then there you have your final answer. I know it's a little bit weird at first, but when we do a few problems, I think you'll see that it kind of becomes automatic. What if you have 5x minus 10y over 25xy? So here I have a fraction where I have kind of like one thing in the bottom, and I have 2 things in the top linked, in this case, by a subtraction. So this is like a big fraction that I can split apart. I can say I'm going to have 5x over 25xy. I'm going to link it with a subtraction because of the subtraction here, and I'm going to have 10y over 25xy. And if this makes you uneasy, then just try to go the reverse direction. If I say, hey, add these fractions together, or subtract them really, because I've got subtraction going on, what would you do? You'd say, well, I've got a common denominator, so I've got a common denominator in my answer, and I just got to take 5x minus 10y, because I just subtract the numerators, 5x minus 10y. So these 2 things are exactly the same, and that's why we're able to split them up. So what I have then is I notice in this fraction I have an x on the top and an x on the bottom, so they disappear, they divide out. And then here I have a 5 and a 25. So I can simplify this fraction just like any fraction. I can divide the top by 5, and that's going to give me 1. I can divide the bottom by 5, and that's going to give me 5, because 25 divided by 5 is that. So the final answer is going to be 1 over 5y, right? And then over here I still have some work to do. I have a y on top and a y on bottom, so they get rid of each other. And then I need to simplify this fraction, 10/25. So I can divide top and bottom by 5. Divide the top by 5, I'm going to get 2. Divide the bottom by 5, I'm going to get 5. And so this minus sign stays along. I'm going to have 2 on the top over 5 times x. And this is the final answer, 1 over 5y minus 2 over 5x. And all of this cancellation I'm doing here in a different color, this is exactly how I do it on my paper. I'm not doing this for your benefit. I'm not trying to say, oh, I'm teaching a class, I'm going to show you this just so you can understand it. This is really how I do it, and this is how everyone should do it, in my opinion, because you can see exactly what the student was trying to do. You can see, all right, they split this up. Okay, he canceled some stuff, and then she went over here and did this, and then we simplified the answer. And if you make a mistake, you can easily look back and say, oh, well, you messed up right here, and then you can fix your problem. You can learn from your mistakes. So make sure you're showing every step along the way. You can go back through here and trace your work. All right, what if you have 3x squared plus 6y cubed, all divided by 3 times x squared times y squared? Okay, so it fits the same pattern. I have one thing on the bottom, one term, and then I have 2 terms on the top linked by a plus sign. So I know pretty much automatically that I can easily break this up into 3x squared over the bottom, which is 3x squared y squared, plus sign comes from this plus sign here, and then I can have 6y cubed over 3x squared y squared. And again, if this makes you uneasy, cover it up and see, does it make sense? Well, if I add these fractions, I have the same common denominator, so I'm going to leave it there, and then I just add the tops, which is what I'm doing here. I can't really make it any more clear than that. You're just adding fractions. That's why you're able to split it up. So now you try to cancel. I see here I have a 3 on top and a 3 on the bottom, so they disappear. I have an x squared on the top and also an x squared on the bottom, so they disappear. All right, so for my first fraction, I have a 1 on the top. Now don't forget, when you cancel things, it doesn't mean 0 pops up, it means 1 pops up. Because really when you cancel 3 divided by 3, you get 1. When you cancel x divided by, or x squared divided by x squared, you really get 1. So what you're left with on the top here is 1. On the bottom, you still have your y squared. All right, now you go here and you realize 6 divided by 3 is 2, so you cancel this out and just write a 2 there. And now you see that you have y cubed and y squared, and we've done this type of simplification before. Here you have like 3 y's on top, y times y times y. Here you have 2 y's on the bottom, which is just y times y. So both of those y's can cancel with 2 of those y's there, leaving me only 1 y left. So I kind of replace that exponent. So for my next term, I'm going to have 2 times y to the first power, so I can sort of not write the first power there. On the bottom, I'm going to just have x squared. So the final answer is going to be 1 over y squared plus 2y over x squared. And that's the final answer there. So I hope you can see that these things, especially with the cancellation, can get tricky, but really, you know, with practice, that's how you get good at it, is just with practice. Speaking of practice, let's do a little bit more complicated problem, but same idea. So 15a cubed b squared minus 10a squared b cubed. All of this is divided by the monomial 5a squared b squared. So again, same thing. I've got 2 terms linked on the top by a subtraction, and I have 1 term on the bottom. So I can split this up. 15a cubed b squared, a cubed b squared, I can write it over this, 5a squared b squared. I have a subtraction here, so I link it with a subtraction. 10a squared b cubed, right there. And on the bottom, it's the same bottom, 5a squared b squared. By now, you should understand that this makes total sense, that we're not doing anything tricky here. Now we look to cancel things. 15 divided by 5 is 3, so I replace that with a 3. Here I have a cubed and a squared. So 2 of these, or I should say both of the a's on the bottom, which is 2 of them, is going to cancel with 2 of the ones on the top, leaving me with 1 left. So I replace that exponent there. Both b's here, b squared cancels with b squared, so they're gone. And so for my first term, really all I have is 3 times a. Because everything else is gone on the bottom, that's just basically 1 down there. 3a to the first power, that's the only thing left. Over here I have 10 divided by 5, gives me 2. And here a squared cancels completely with a squared, so they're gone. And b squared, and I have b cubed, so both of these b's are going to cancel, and I'm going to be left with only 1 b on the top. So what I have is a minus sign coming from here, 2 times b to the first power from this 1, so I just don't have to write that. The answer is 3a minus 2b. And that's the final answer. So I think you'd agree, if you look at this stuff in a textbook, it looks super complicated. But with practice, really all you're doing is the same thing over and over again. We're getting lots and lots of practice doing it. All right, we're winding our way through our problems. We're over halfway done. What if we have 4x minus 2y plus 8z, and this is all divided by 4xy. And I say, simplify this, or I say, do this division, basically. Divide by this. So notice what you have. It's a little different than before. On the top, I actually have a trinomial, 3 terms. On the bottom, I have a monomial, so I'm dividing by monomials. I want to simplify all this stuff, but it's a little different than before. But I think you can convince yourself that the same basic thing is going to happen. What I'm going to break this up to is going to be 4x over 4xy. From this guy. I have a minus sign here. I have 2y over the same thing. and then I have a plus sign here, and then I have 8z over the exact same thing. Now, this should make total sense to you. We're following the same pattern, but if it doesn't, just cover it up and see what you have. You basically have the same common denominator. If I asked you add these fractions, same common denominator, so that would be in your answer, then you would have 4x minus 2y plus 8z. You just add the numerators together. There you go. If these were numbers, it would be done exactly like this. It just looks more complicated, even though it's not. So now I go and try to simplify. Here I have 4 cancels with 4. I also have x cancels with x, so that's all I can do there. So I have 1 over y. Don't forget I have a 1 up top, even after everything is canceled. So I have a subtraction here, and y cancels with y, and I have a 2 and a 4. So this is like a, any kind of fraction or whatever, you can always simplify it. Let me divide the top and bottom by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So really I have 1 over 2x. That's the only thing left over here. 1 over 2 times x. That's all that's left. I have a plus sign because of this, and now I try over here. 8 divided by 4 is 2. And there's nothing else I can cancel. Z and x and y are all different. So really what I have is 2z over x times y. And this is the final answer. So what I have is 1 over y minus 1 over 2x plus 2z over xy. And that's the final answer. So notice that if you have 3 terms on the top, it doesn't really make it that much harder. Once you split it up, you just have one more item to deal with. Now what if I have 12x cubed times y squared minus 8 times x squared times y minus 4x, all divided by 4xy. All right, 4xy. So I've got a lot of terms, 3 terms on top. Again, they're just more complicated terms, and I have 1 term on the bottom. So rather than cram it in here, I'm going to write it right below. This is equal to, you break each term up just like we've done, 12x cubed y squared over 4 times x times y minus, because I'm linking with a minus sign, I have 8 times x squared times y over the same denominator, 4 times x times y, minus 4x on the top, 4xy on the bottom. Right? So those are the 3 things I have, same as before. Now I try to do some simplification. 12 divided by 4 gives me 3. I have 1x on the bottom and 3 on the top, so this x is going to cancel with one of these, leaving me 2 x's behind. I just kind of remind myself with that too. This 1y is going to cancel with this guy, leaving me 1y behind. So while it's fresh in my mind, I'll have a 3 up here times an x squared times a y, x squared times a y to the first power. Only a 1 on the bottom, so I don't have to write it. I'm linking with the minus sign. 8 divided by 4 is 2. And then I have x here is going to cancel with one of these x's, leaving 1 behind. Y is going to cancel completely with this one. So I'll have in the end 2 times x to the first power. That's it. That's the only thing left for that term. And then I'm linking with this minus sign. 4 cancels with 4, x cancels with x. The only thing I really have left is 1 over y. So this is the answer. I have 3x squared y minus 2x minus 1 over y. Looks complicated, but this is about as simple as you can get it because you can't add any of these terms. You don't have like terms anywhere, so you pretty much just have to leave the answer as it falls out. All right, we're almost done. We're working our way through our last few problems. What if we had 5x times 4x minus 2y all divided by 2y? Now this looks a little different because we have this parentheses going on in the top, but don't forget the stuff we've learned before. The 5x needs to be distributed in to both of these guys before we can do anything else. So 5 times 4 is 20. X times x is x squared. All right. The minus comes here, and 5 times 2 gives me 10. X times y is xy. Everything on the bottom is the same. So now this looks familiar with what I've done in the last few problems. So I can split this fraction up. 20x squared over 2y minus, because I'm linking with this, 10xy over 2y. The only thing different is I had to do this distribution first before I could do anything else. All right, so now we go back to trying to simplify this. We have 20 divided by 2, which is going to give us 10. And we have x squared over y, so we can't really simplify this. So it'll be 10 times x squared over y. Over here, we're going to have 10 divided by 2, which is going to give me 5. And y cancels with the y on the bottom. So we have a minus sign, 5x from here. So the answer is 10 times x squared divided by y minus 5x. So what if you have negative 2x all raised to the third power plus 3x squared raised to the second power, and you're dividing all this stuff by 6x squared? How we handle that? Now notice everything looks the same. The only problem is I've got these exponents here, so I need to deal with these first. So I have negative 2x all raised to the third power. So this 3 as an exponent gets distributed and applied to each one of those. So negative 2 raised to the third power is negative 2 times negative 2 times negative 2. So you're going to get negative 8x cubed, because this is going to go in like this, plus over here 3 squared, 3 times 3 is 9, and then x squared squared, you multiply the exponents. 2 times 2 is 4, so x to the fourth power. And on the bottom, you'll have 6x squared. So now, once you do that initial work, everything is in the form that we know what to do with. So we have a binomial on the top, and we have a monomial on the bottom, so we can split this up so we can easily cancel. Negative 8x cubed over 6x squared plus 9x to the fourth over 6x squared. It's the same thing we've been doing every time. Now we try to do some cancellations. What we're going to have here, x squared, we have 2 x's on the bottom, is going to cancel with 2 on the top, leaving only 1 x on the top. And this 8 over 6 we can divide by 2. So to simplify it, so 8 divided by 2 is 4, 6 divided by 2 is 3. That's about as much as we can simplify it. So what you're going to have on the top is negative 4 times x. On the bottom, you're going to have 3, because that's all that's left, x to the first power, and you have a 3 on the bottom. Now you have a plus. Let's go over here. We can simplify 9, 6. We can divide by 3, giving us 3 there. We can divide by 3, giving us 2 there. The x squared, 2 of these x's, can all cancel with 2 on the top, leaving 2 x's behind on the top. So you're going to have 3x squared over 2. That's going to be your final answer. Negative 4x over 3 plus 3x squared over 2. All right, here's our final problem. What if we have 3x minus y times 2x minus 3y, all divided by 6xy? All right, so there you go. It's the big kahuna. You have to kind of put together everything we've learned. On the top, you have this binomial times binomial, so you need to use FOIL on the top before you can even do anything else. So let's do that. Over here, first term times first term. 2 times 3 is 6, and you have x squared. The outside terms, 3x times negative 3y, is going to give you negative 9 times x times y. The inside terms, negative y times 2x, is negative 2xy. And then the final terms, negative times negative is positive 3y squared. All right, and on the bottom, you have 6xy. Now, on the top of that fraction, before we do anything else, we see that this is a like term with this because I have xy here and xy here. So I can simplify that. 6x squared. What is negative 9 minus 2? It's going to be negative 11. Xy have to come along for the ride. And then I'm going to have my 3y squared, just as I always have it. And then on the bottom, I'm going to have 6xy. Okay, so now I'm to the point where I can do what I've done in all of these other problems. So let me go ahead and split this up. So what I'm going to have is splitting this up, 6x squared over 6xy, minus from here, 11xy over 6xy, plus from here, 3y squared over 6xy. So basically we split them all up the same as we have before, and now we look term by term. 6 cancels with the 6. This x cancels with one of these x's, leaving one x behind. So when we write our final answer, all we have in the top is x, and all we have on the bottom is y. We have a minus sign because of here. The x cancels with this x, the y cancels with this y, so the only thing we have left is 11 over 6. We can't really simplify that anymore. We have a plus sign from here. We'll divide the top by 3 and divide the bottom by 3. It gives us 2. And then this one y can cancel with one of these y's, leaving me one left over. So on the top, all I'm going to have is y to the first power, which I can just kind of erase and just have y. On the bottom, I'll just have 2x. And that is the final answer. So x divided by y minus 11 over 6 plus y over 2x. And that concludes how to divide polynomials by monomials. Basically, you have something linked together with pluses or minuses on the top of a fraction. You're dividing by one term in the bottom. That's why it's called dividing polynomials by monomials, because it's simpler, believe it or not. We're just dividing by the simple monomial on the bottom. The easiest way to do it is to bust everything up into their own little fractions, and then you can do all the cancellations that we've learned, and then you can simplify the results. Basically, you're kind of putting together lots of skills that we've learned throughout the class and kind of rolling them into one kind of topic here is what we're really doing. So this kind of division is a little bit simpler because mostly it revolves around canceling terms, and then you get the answer. In the next section, we're going to have dividing polynomials, which are, you know, multiple item things linked together, divided by more polynomials. So you're taking something big, dividing it by something else big. So there's some other things to think about when we get there. So make sure you watch this section as many times as needed to make sure you understand it. You should be able to work all of these problems and get them right. Work extra problems either from my companion worksheets or from your textbook. Make sure you can work those all fine, and when you're comfortable and confident, move on to the next section. We'll continue learning how to divide polynomials by polynomials.